Okay, we're still just differentiating implicitly. So here we're going to take d dx of each term. And then let's get started on that. Okay, so we have the derivative here. So we're going to have, what's the derivative of cosine? Sine, negative sine of that term, so that's derivative of the outside, but we also have the derivative of the inside, so using chain rule. So we're going to have d dx of xy. Okay, we look over here to the right. What is the derivative of 1? 0. What's the derivative d dx of negative x squared? Negative 2x. Good. All right, so that part's not too bad, but here, this term, we're just going to bring down. But when we calculate the derivative over here, what are we working with? Yeah, product rule. So first times derivative of the second plus second times derivative of the first. All right, so we're going to calculate that. Okay, so we show that product rule right there. Let's go ahead and simplify that. So I'm just going to bring this down for now. So we'll have x. What's the derivative of y? Just 1, but we have dy dx. So it's 1 dy dx. So I'm just going to say dy dx. Plus we have y. What's the derivative of x? Just 1 there. So I'll just show that. Okay, let's next up, let's algebraically simplify this a little bit. Okay, so distribute here, check your answer on that. The next thing is to get the dy dx term by itself. So I'm going to move this term to the other side. Okay, and our last step is to get dy dx by itself. So divide both sides by this, and we'll be done. And then if I wanted to change all the signs of this so I didn't have this negative down there, that would just give me, let me simplify this a little bit. So we'll get dy dx is equal to, change all the signs, so 2x then minus y sine of xy over x sine of xy. Okay. Okay, so we've done a little bit of practice with that. Let's look at this next example where they give us this relation. They ask us to evaluate it. We're going to evaluate the derivative at the particular point, negative 2, 1. So we're still going to do the same process. First thing we're going to do is actually, let's multiply this out. So if you FOILed this out, we would get x squared plus 2xy plus y squared. Because that need to be FOILed, let's just algebraically see if we can simplify this a little bit. Now, I can simplify this even before I start. What if I subtract x squared and subtract the y squared? What would that leave us with? Yeah, 2xy equals 0. We know that anytime we can simplify stuff algebraically, it's probably going to be in our favor. Now we're going to take d dx of both sides. So d dx. We have a 2xy term on the left and 0 on the right. So over here we're going to have, we can just pull that out as one term and this is the other. So we'll have product rule. So go ahead and write that step down. Okay, first times derivative of second plus second times derivative of the first. Okay, bring this down. Derivative of y is just 1, but we have dy dx, and then derivative over here is just 2. So 2x. Next thing is we want the dy dx term by itself, so I'm going to have 2x dy dx. I'm going to move this term, which is 2y, move it to the other side, so I just have minus 2y, and we solve both sides for dy dx, so dy dx is just going to simplify to what, negative y over x. Okay, this is our equation for slope. That's what we've been finding. Now for this particular example, they want us to evaluate it at this point, which is we have an x value and a y value. So basically I'm going to take my negative y over x that we found, this slope, and evaluate that at the ordered pair negative 2, 1. So when y is 1 and x is negative 2, we get this, which simplifies to 1/2. Okay, we're going to do another problem like 6. This one I want you to try on your own, so if you can simplify it, do so. If not, go ahead and take the ddx of each of these terms and get started. Once you find the equation for the slope, then evaluate it at the point 1, 2. Okay, so basically take ddx of each term. Then all of these terms, I could take a dy dx out as a common factor, and we would be left with this parenthesis. Of course, this 2x term was moved to the right. Divide both sides by the parenthesis. This is our equation for our slope. We evaluated at the ordered pair 1, 2, and that's going to give us 2/3. So pause it and check your work on that. Now I could extend this a little further to what we've been doing. I said, if this is my slope, find the equation for the tangent line at that point 1, 2. So this is a slope at 1, 2. If they ask us to find the equation for the tangent line, we can do what we've done previously. We can y minus y1 equals mx minus x1 using the 1, 2 as our xy and 2/3 as our slope. It would simplify to y equals 2/3 x plus 4/3. Okay, this is the first time we've seen this. Once we find the equation of the tangent line at that point, we can also be asked to find the equation of the normal line at that point, which this is basically perpendicular. So if my slope is 2/3, and I plug that in to get the equation of the tangent line, to find the normal line, what would be opposite the perpendicular to this? Negative 3 over 2. So basically all I need to be able to, I'm going to use the slope negative 3 over 2 in my point slope form. So do that in the next part. Okay, so when you simplify that, we'll have this. This is just the normal line, which is perpendicular at that particular point. Alright, if we have to do a second derivative of this particular given function, so take ddx of each of these terms and get started. Take this as far as you can. You should be able to be pretty comfortable finding the first derivative on your own now. Okay, so check your work on this. This is where we grouped our dy dx terms, and this is our first derivative. So now we have to differentiate again. It's implicitly. So what will we do here? Quotient rule, right? Low d high minus high d low over the square of what's below. So set that up. Okay, check your work on that. Over the square of what's below. This next step, we're going to just focus on taking the derivative here and the derivative here. Okay, so you have all that. Oops. And don't forget over the square of what's below. So check your derivatives there. Okay, and typically when we're finding the first derivative, we would solve for the dy dx term, but in this case, we already know this term. We know the value of it, right? We found it up here. So to find the second derivative, you're going to have a substitution of your previous. So y double prime, our second derivative, is going to be, we're going to carry all of this down, 4y cubed plus 3, 24x. Just make your way across. Then I'm going to have 12y squared. This, let me see if I can highlight this so we can, dy dx, I'm going to replace with what we found for our dy dx. Okay, so in simplifying this, we did a lot of steps all at once, so let me just kind of explain. So first of all, in the numerator, if I got my common denominator to be 4y cubed plus 3, that means that one would need another one of those, so that would give me 2 terms there. Of course, that's just brought down. Subtract, have this term which is brought down, the 12y squared, but also have this one. So this and this would be why we have two of the terms. And when we have this written in the bottom as our common denominator, we move it to the bottom, we're going to have three of those terms.